This assignment allowed us to add artificial sensors and GPS to our aircraft, creating a more realistic data into our system. The first thing here is just to go through our sensor equations and output them here. In order to create the random error that we'll see inside of our sensors, we just multiply the standard deviation by this random function in order to give us a random number that adds to our initial reading, emulating the censored output. All these equations here are found on the slides on their respective pages. Similar things can be found in the GPS data, where we have different GPS outputs. We have to make sure that all these are initially 0 at the beginning, and these equations were also found later on in the slides. These two things combine to create an output of 13 different variables that we can see in our simulation. I ran the simulation at 45-degree heading and at about 100 meters elevation. All the 13 individual sensor readings are shown here, and we can see that they all very much make sense. We have the pitch, roll, and yaw from the gyroscope here. Next we have the accelerometer readings. We see that x is fairly constant except at the beginning before it changes and heads in the 45-degree direction mark. And the y direction also accelerates at the beginning as it hits that, and then levels out as it just hits in a constant velocity at 45 degrees. And with our Z accelerometer, we're at about negative 9.8 here, which is due to gravity. And finally, we have our different pressure values here that come from static and differential pressure based on the altitude and airspeed of the vehicle. Both these numbers also seem to be about correct. Then we can move on to our GPS sensors here that show the heading in the X and Y direction. As you can see in X, it starts along a constant velocity and basically maintains that the entire time, and Y, you can see as it slowly turns into that direction, it starts heading on a constant velocity as well. And finally, the Z from the GPS, or height, also has some deviation around the 100 meter mark, which is what we inputted into our simulation. Next, we have the ground speed here, which hovers around 47, just as expected, and the heading mark, which is at 0.8 radians, which is exactly at 45 degrees, which is what we set. I can now show the simulation running here, and you'll be able to see that's all working. As you can see here, we have the airspeed command 35, altitude 100, and course at 45. And you can see our readings here are just as expected. One final note is that I had to change a bunch of the gain values in my compute autopilot gains file in order to account for the change in how our system works. Previously, we were taking things in continuous time, but now, due to our sensors, everything is discrete, and all the values had to be changed in order to retune our airplane.